Okay, so again, this is basically probability lectures continuity, chapter 4, that is continuous random variables and probability distribution. So we will done previously, I think chapter 2 and 3 or 1 or 2, I don't remember, but inshallah I will complete this. Again, I have to start with the numericals. Okay, then. So the first numerical about this is example 6.6. It says that let x the thickness of certain metal plate. That let us say that I have a metal plate. Okay, I have metal plate like this one. Okay, so it has the thickness of what? It has a thickness of x. Ever uniformly distributed on A, comma B. Yes. What does this mean? A, comma B. A, comma B means that I have function. Function basically, I have to write here again. There is x-axis and y-axis. Okay. So in x-axis there is always f, and in y-axis there is function of x, which is the value of y. Okay. So it says that it is A, B having uniform distribution. So uniform distribution must be here on x-axis. Let us say this is my point A and this is my point B. Having some thickness, so this will be elaborated as it will start from this point and this point, and this point will be equals to 1 divided by B minus A. Why 1 divided by B minus A? Because this is the value of y. Okay, so this is the inverse of the difference of the values which is in x. So it will be like this one and this one. Okay, let's take a midpoint of this. Let us say this is the midpoint, approximately midpoint. This will be x. So this is the shaded region. So this will be what? This will be function of x, f of x. So this is the general elaboration that how we made our graph respective to uniform distribution on a certain horizontal axis or vertical axis. So this is the distribution. So for the given is for x is less than a. If x is less than a, this means that if the value of x is less than a, this point. Okay, so it says that if it is less than a, so what does this mean? That function of x equals to 0. So this means that then if this value x value is less than a, that x value is less than a, so my function value will be equals to 0. So this means that behind this point, this will be 0. So this will be shaded, or there is a straight line, this one. So this line shows basically the function when x value is less than a, so my function value will be equal to 0. Is it clear?
Yes, sir.
Okay. Since there is no area under the curve, yes. So since there is no area under the graph of the density, so as there is no area under the curve, this means that there is no area under the curve, so the function value must be equals to 0. Okay. For x is greater than or equals to b, this means that if my system is this one, that x is greater than or equals to b, this means that it may be this point, b point, or greater than this point. So what does this? He says that the function f of x equals to 1. So there are two limits. Two limits are if x is less than a, my function value equals to 0. And then if x is greater than or equals to b, my function is equals to 1. So I have two values, a and b. A and B respectively. So my value must be less than equals to B. That is my highest value, and it must be less than equals to A, greater than equals to A, sorry. So these are the points. So I have to take the differential. So for this, it will be function f of x. F of x will be written as the integral of f of y dy. So what is f of y dy? Means that function of y. So function of y must have 2 points. It must have the x point, x, and there must be a negative infinity. Okay, so how we elaborate or find these points? Basically, this is my upper point where my value is always equals to 1, and there is my second point. This is basically the point where this value goes to negative infinity. So I take these 2 points, whether my point will be x will be what, x will be this point. Okay, for positive infinity it is denoted as x, and for negative infinity it is basically elaborated as minus of infinity. Okay, so these are two initial and final limits. So these are my limits, upper and lower limits. Now applying the limits and coordinate function. So it will be, what is the function of y? So function of y given is 1 upon, function of y is also given. Function of y equals to 1 upon this one, 1 upon b minus a. Okay, so this is the function which is also given to us. So I have to put this value, I so I have to write it again, sorry. So it will be written as f of x with the upper x and negative infinity, f of y d of y, now x, and now lower basically is LA, and then 1 upon b minus a dy. So I have, this is my constant. I will take this constant behind my integral. So it is 1 upon 1 minus b minus a, then the integral of x and a, and then the taking the integral values dy. So the integral of dy is, I have to write here again. So it will be 1 upon b minus a with a value of this integral, that is y, and having lower limit equals to, upper limit equals to x and lower limit equals to a. Okay, so when applying this, it will be, I have to write here, I have to make some place, I have to delete this. Now this value will be then, it will be written as 1 upon b minus a, then applying what value, applying the value of x. So this will be y, so putting y equals to what, upper limit is x, so it will be x, and lower limit is ax minus a. So we can write as x minus a divided by b minus a. So this is the value of function of my f of x for this interval having a and b points. So this is how we find the value. Okay. Now this is basically 3 points. Now I have to make an assumption that when it is x is less than a, my value is 0. When x is greater than equals to b, my value is 1. And when it is between this interval, so it will be x minus a divided by b minus a respectively. So these are the 3 points I find. Okay, so this will be, so my graph will be like it has equals to 0 when it is less than a. So here it is the point a, and when it is less than, so this value is 0. And when it is greater than equals to b, so my value at b will be greater than or equals to this point, so it will be 1. And in between this, I have this region. So this region will be my slope, which will be x minus a divided by b minus a respectively. So this is how we complete our problem by describing. First, I will describe the upper and lower limits. Upper and lower limits for my function is x and negative infinity. Then applying the integral, then solving it, and then computing 3 points. X is less than a, x is greater than equals to, and then there's the interval between a and b. So by finding this, I make a graph, and this graph is the final basically elaboration of this example 6.6. Okay, now the next problem is 7.7. Solve the suppose the PDF of the magnitude x of a dynamic load on a bridge in Newton is this one. That is f of x equals to 1 upon 8 plus 3 upon 8x. When the interval is x is less than equals to 2 and greater than equals to 0. That it started from 0 till 2. And otherwise, when it is less than or equals to 0, all the values are 0. Otherwise, the value is 0. I have to find the value of f of x. So it will be, I have to take the integral. So it will be f of x will be taking the integral of f of y dy. Having two limits. First limit is x and second limit is minus infinity. Okay. So what is the first limit? First limit is x. X basically this is the limit. And second limit, negative infinity, is always the other limit. The other limit is basically shown as otherwise. Otherwise, the value is what? Value is 0. So I will write here that it is x at upper limit and lower limit it is 0. And then f of y will be this one. So it will be 1 upon 8 plus 3 upon 8. Basically, this is y, function of y. So I will write, I will replace this y, x with y, and then dy. Then taking the interval, so it will be x upon 8 plus 3 upon 8 with the integral of this one. So it will be x square upon 2. I will write as x upon 8 plus 3 upon 16 x square. So this is the value of f of x for my system between 0 and 2. Okay. Now again, moving towards, thus I have computed 3 points. First point is when x is less than 0. When x is less than 0, it is 0. And when x is less than equals to 2 and greater than equals to 0, so my function will be this one, that it will be equals to x upon 8 plus 3 upon 16 x square. This is for this limit between 0 and 2. And then when x is greater than 2, so this value is always 1. So these are the three values we find. Now moving towards the graph. So graph basically, when my value is 0, when it is x is less than 0, so it will be 0. So at 0 it will be 0, and it will be a linear graph showing that there is a x upon 8. Okay, x upon 8, this is basically the graph of this function, this value basically the this is a this is a linear function, and this is basically there is a scale of the value, so this highest power is 2, so this is a quadratic function. So these are two values. First is when the highest power is 1, so my function or my line basically is a linear line or a linear function. When it is square, when it is 2, so it will be quadratic function respectively. So these are the two ways to elaborate or find the value. Okay. Now for the second part, I have to find the probability that the load is between 1.5 and between 1 and 1.5. So how to find these questions? So for this, I have to find the P which is my load. And firstly, the value of X having upper limit that is less than equals to 1.5 and greater than equals to 1. So this means that this value will be f of 1.5 minus f of 1. So I have to find the upper limit and lower limit respectively. So as I find it, this is basically I find in the first part, this is the value x upon 8 plus 3 upon 16 x square. So I don't need to follow these steps again. So I have to find this value. So it will be 1 upon 8. First it is upper limit is 1.5 and lower limit is 1. So I have to put the upper limit first. So the upper limit is 1.5. So this will be written as 1 upon 8 and x. So x will be for first it is 1.5. So x will be replaced with 1.5 plus 3 upon 16 x square. So it will be 1.5 square. And for second 1 upon 8x plus 1 upon 3 upon 16 1 square. So that is x square. After elaborating, after simplification, this will be 1.5 8 plus 3 into 1.5 square divided by 16, then minus of 1.8 plus 3 upon 16. So this will be the value that 19 upon 64, and the answer is 0.297. So this is the how we find the value, probability value between 1 and 1.5. Okay, now find the probability that the load exceeds 1, that my value of load exceeds the value equals to 1. So how to find it? So this will be when its value is greater than 0. So probability will be when its value will be 0. So it will be 1 minus probability that x is less than equals to 1. So less than equals to 1 means probability of f of 1. Okay, so f of 1 is this one. Okay, so I will write this as probability x is greater than 1 minus prob f1. So f1 will be 1 upon 8, 1 which is given here. Okay, so plus 3 upon 16, 1 square. After the calculation, I can find the value of my system. So this value is approximately equals to 0.688 or 11 upon 60. Okay, this is the end of this numerical. Okay, moving towards the next one. It says that when x has a uniform distribution, f of x is differentiable except at x equals to a and x equals to b, where the graph of f of x has a sharp formula. Let us say that I have 3 points where I know that when x is less than a, so my function value is equals to f of x equals to 0. When x is greater than b, so my function value will be equals to 1. And for when there is derivative of f of x, so it will be 0 because constant derivative always equals to 0. So for this, for interval a and x, with x is less than equals to b, so I find by using formula in the previous example that this value equals to x minus a divided by b minus a. I have to derive this. F derivative of x equals to 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 what? X upon x minus a divided by b minus a. X minus a divided by b minus a. So it will be written as 1 upon b minus a. So 1 upon b minus a is what? Function of f of x. So this is the way that I elaborate the value between the values a and b. Okay, now moving towards the next one. Example 4.9. For example 4.9, I have given certain values. So these values basically are changing with respect to time or some parameters. So if it changes with respect to x, so it will be 3 upon 2 into 1 minus x square with interval of x equals to x is less than equals to 1 and greater than equals to 0. And all the values except this point is 0. Okay. So we have to find the CDF and f of x for my function. So the CDF of sales between 0 and 1 will be what? I have to write here again that my integral will be f of x with upper limit x and lower limit is what? Lower limit is 0 with the function value 3 upon 2, 1 minus y square dy. So it will be 3 upon 2 with y minus y cube upon 3 with the upper and lower limit will be x and 0. So it will be 3 upon 2 x minus x cube divided by 3. So this is the way we find the value of f of x for my function, which is equals to 3 upon 2 into x x minus x cube upon 3. Okay, these are the simplest value to find by using the integral function. Okay, moving toward the next example. Now, first I have to find that f of x is basically this one with a x square, and my capital F of x is the x cube. So one is the quadratic function, other is the cubic function. So this will be for square function, it will be like this curve, and for my cubic function, it will be like that. Okay, then give me 2 minutes, please.
No problem, sir. Take your time.
Okay, thank you. This is this is how we find the values of function and f of x for my given system. Let us say the question is the 100th percentage or percentile of this distribution satisfies this equation. Let us say that this equation, which is given that p equals to f of percentage P equals 3 upon 2 NP minus NP cube divided by 3. So how to find it? Basically, we have to use the calculator to solve it. That is, which is third degree equation. The third degree equation, I will write that x cube minus 3x plus 2 into 0.5. So I use the calculator and find that for 58th percentile P equals to 0.5. So from calculator, I use this expression n cube, this one, that cube value equals to first value, this is a value is 1, b value is 0, c value is 3, and d value is 1. C value is minus 3, sorry. So I find that n value for 0.5 is my 0.347. So if the distribution remains the same for week to week, then in long run, 50% of all the week will result sales of 0.347 tons, and 50% and more will mean 0.37 tons. So this is the value that I find for 50%, which will be equal to 0.347. So I will make a statement here that if my sale is greater than 50%, so my value will be greater than, this value. When it is less than 50%, so my value will be less than this value. So this is the way to solve this question, that find a general value, and after finding the general value, I assume that if this value will be greater or less than, so my value will be greater than or less than respectively. Okay. Now moving towards 4.10, the PDF of weekly gravel sales X was this one, that f of x equals to 3 upon 2, 1 minus x square, with the interval this one, and otherwise all the values are 0. So I have to compute the value of E of x. So for E of x, it will be, E of x means what means? E of x means expected values. Okay. So for expected value, my function or my formula is this one. Okay. I have to write here for EA. EA mean expected or mean value. Expected or mean value. So for my expected or mean value, it will be written as mu x or E of x. And taking the integral of positive infinity and negative infinity with x multiplied by function of f of x. Function of, then taking the differential of with respect to d of x. So this is basically by expected or mean value of a continuous value with PDF. Okay, so this is the function. So remember this. Now I have to apply this formula in my equation. So I have to find EX. So EX will be, first I have to write the formula. My EX will be, E of X will be taking the integral with negative infinity and positive infinity. Then X multiply by f of x dx. So what is the upper and lower limit? My upper limit is 1 and lower limit is 0 in this case, or I have to find here. So 1 and 0. Then the x of x Now f of x, so f of x is this one. I have to place here. So it will be x into 3 upon 2 with the value 1 minus x square d of x. So this is the method to represent uh, basically my function in e of x expected mean value. So now taking 3, so 3 upon 2 common, or this is basically constant, so I have to take 3 upon 2 in front, so it will be integral of x. First I will multiply x with 1, so answer will be x, and x will be x square, so x cube. So it will be x minus x cube, so it will be x2 divided by 2 minus x4 divided by 4 with upper limit 1 and lower limit 0. So again I have to write here that it will be 3 upon 2 with x2 upon 2 minus x4 upon 4 with x value equals to 1 upper value and lower value is 0. Okay, so it will be 3 upon 2. Now x square will be 1 square divided by 2 minus 1 square 1 power 4 divided by 4 with a negative sign with 0 divided by 2 minus 0 power 4 divided by 4. So after the elaboration, okay, just give me 1 sec. So after the elaboration, my value will be 3 upon 8 respectively. So this is the E of x, which is basically the question will be, we have to find the expected value. Okay, so the symbol of expected value is E with the random value variable x. So it will be E of x, which is my expected value. Okay. Now next for this one, you have to remember that this is the expected value for a discrete case. So I have to write here that E of x, first I find the E of x. Now I will find that E h of x. Okay, that E h of x. So E h of x, the formula will be different. So it will be E h of x will be mu h of x equals to integral with positive infinity and negative infinity with h of x multiplied by function value f of x. So this is basically for a step function. Okay, so if x is continuous with PDF f of x and h of x, so now there are two values. First, the value of function f of x. Now secondly, the next value is h of x. So this is why I used this formula when I have two variables. Again, first variable is h of x, f of x, sorry, and second is h of x respectively. So this is how I find the values. So by taking the integral, first integral of h of x with function with the upper limit with the upper limit infinity and lower limit negative infinity. Now moving towards the example 4.11. So my 4.11 example will be, now two species are competing in a region for a control of limited amount of certain resource. Let X be the proportion of resources controlled by specimen X, specimen 1, and suppose the X has a PDF with function value equals to 1 when X is less than equals to 1, or it is basically greater than 0 and 0 otherwise. So which is a uniform distribution on 0, 1, and then I have to find the values with respect to this one. So how to find the value? How to find the value of my system, as the majority of the resources are h of x, that max x and 1 minus x. One is 1 minus x with this interval, and the x value for the other interval with half and 1. So it will be 0 till 1 upon 2 and 1 upon 2 till 1. So for this, the value is 1 minus x. And for this, my value equals to x. I have to compute the system or E with respect to h of x. Okay. So as we know that this value equals to the integral of this one with the derivative of the function. So it will be E h of x will be taking the integral with positive infinity and negative infinity with max x comma 1 minus x with f of x and d of x respectively. So this is the formula to find the value. So now will have to compute it in the formula. So it will be now f of x of function value. So function value given is 1. So here it is 1. So my value will be f of x will be 1. I have to take the two intervals. First, it is from 1 to 0, but it is piecewise function. Piecewise function means this is the first interval, that it started from 0 to 1.2, 1 upon 2, and second is 1 upon 2 to 1. So a discrete function started from 0 and it ends at 1. Okay, so this is the basic rules, that if there is a complete interval 1 and 0, so I have to split in my piecewise function. So piecewise function will be 0 till 1 upon 2 and 1 upon till 1. Now for the first value, this value equals to, I have find that first value equals to 3 upon 8. Okay, and second by integral, so this value equals to 3 upon 4 respectively. Okay, now this is the, I think, last 4.12. Okay, now this is the shortcut formula. Okay, shortcut formula to find the employed and discrete case. So it will be v of x, it will be equal to e x square minus e of x whole square. So this is the value of my function with v of x. Okay, so for weekly gravel sales, we computed E of x equals to 3 upon 8, and we have to find the value of E of x. So as we know that, first I have to write the formula that by E of x will be, I have to write here, sorry, V of x will be E x square minus E into x with the whole square. Okay. So first thing is we have to find the value of E of x. E of x square. Okay. So I have to write it here that it will be E x square with the integral values negative infinity to positive infinity with the x square f of x into d of x. This is a general formula to find the ex square. Now we have to find it. So the first way to find is taking the upper and lower limit, that is infinity and negative infinity limits. As this limit is, for my case, it is 1 and 0. So I have to find, I have to put these limits in my equation, and the x square and f of x value. The f of x value is 3 upon 2 into 1 minus x square. Just give me 1 second.
No problem.
Okay, so it will be the value Tx square with, this is the x square value, and this is the function value. So for this, I have to take this value as a constant, so it will be 3 upon 2 with the integral upper and lower limit, then x square multiplied by 1, so x square, and then x square multiplied by x square, so it will be x cube, x4, sorry. So these are the two values of my x, that is x square. So I have to integrate here, so it will 3 upon 2 with the integration, so it will be x cube divided by 3 minus x5 divided by 5 with the upper limit 1 and lower limit 0. So 3 upon 2 into 1 upon 3 minus 1 upon 5. It will 3 upon 2 with the LCM value is 15. Then 5 minus 3. So it will be 3 upon 2 multiplied by 2 upon 15. So it will 2 will cancel out 2 1 and 3 ones are 3 and 3 5s are, so my value will be 1 upon 5 respectively. So this is how we find ex square. This is the first part of to find the value of v of x. Now to next value is I have to find ex whole square. Okay, so as the value of ex given is this one, 3 upon 8. So we can find the value as, this value will be written as, then this value will be v of x with e of x square minus e x whole square. So it will be ex whole square value 1 upon 5 that I find. Now the value of ex is given, so it will be 3 upon 8 square.
Yes.
So it will be 1 upon 5 minus 3 square will be 9 upon 8 square is 64. So after the LCM, it will be 19 upon 320. So 19 upon 320 is 0.059. Okay, so this is how we find the value of the system of v of x. Now a of x is sigma x is 0.244. So where h of x is a x plus b. So if I represent with respect to e h of x and v h of x, so e will be written as a mu plus b, and v will be a square into sigma square. So sigma square value will be this one. Then putting the value, and we can find the values of these two respectively. So this is the way we can find the value of v of x. Again, v of x is also my expected value, but the variance and standard deviation basically gives two types of things. So first will be my v of x value, which consists of two values. First value is ex square, then the second value is ex whole square. So there's a huge difference between this value, first value, and second value. Okay, so we can find this value by using by applying the operation, and the ex square will be simple. It will be found by using this value. Okay, then this is the completion of this lecture. Any question from this lecture?
No, sir.
Okay, now I am going to start the next slide. Okay.
Okay.
Give me 1 minute to open it. Okay, this one. Where is the next one? Yes, this one. This one with 39. Okay, 30th slide. Okay, this is the next slide. Next slide of continuous random variables and probability distributions. Other continuous distributions, the Weibull distribution. Okay, so what is Weibull distribution, or how we find the Weibull distribution? This is the important slide. Accordingly, basically, Weibull distributions are introduced by a Swedish scientist, Weibull. Okay, so according to Weibull, by there's a note. Yes. Okay, a random variable x is said to be a Weibull distribution with shape parameter alpha and scale parameter beta. Okay, so there are two major parameters in my Weibull. So first is my shape parameter, which is denoted as alpha. I have to write here. Just give me, yes. First is alpha. Alpha is what? Alpha is my shape parameter. And this value will be greater than 0. And second is my beta. Beta is what? My scale parameter. So my beta value must be greater than 0. So to find the value of function of x and alpha beta, so my function will be f of x, that the function with x and alpha beta, and alpha beta, as I said, that it is the shape and scale parameters. So it will be written as alpha upon beta. I will write here again. It will be, yes, alpha upon beta power alpha. Okay. Then multiply with x alpha minus 1 with e value of negative of x upon b alpha. Okay, so this value, for this the domain value x value is greater than or equals to 0, and it is 0 otherwise when it is less than 0, when my x value is less than 0. So this is my Weibull parameters. Again, Weibull distributions says that there must be, it deals with two parameters. First is my shape parameter and second is scale parameter. With my shape parameter is alpha and my scale parameter is beta. So both values, alpha and beta values, must be greater than 0. So it will be written as my function value of x with alpha beta. So it will be alpha upon beta power alpha multiplied by x alpha minus 1 into e having power negative of x upon beta multiple of alpha. So this is the way we find the Weibull parameter. Let's go towards some examples. Weibull distributions. Okay. 4.25. Okay. In recent years, the Weibull distribution has been used to model engine emissions of various pollutants. Let X donate the amount of NOx being nitrogen oxide emission from a randomly selected four-stroke engine of a certain type, and suppose that X has Weibull distribution with alpha equals to 2 and beta equals to 10. Okay, so suggested by information in the article word quantification of variability and uncertainty in the knocks. So this is the information given to us that now Weibull parameters or Weibull distribution is used nowadays in finding the engine emissions. Okay, so the corresponding density curve looks exactly like the one in the following, that alpha equals to 2 and beta equals to 1, this value. Okay, so this is all the information. So now expect that now the values 50 and 100 replace 5 and 10 on the horizontal axis, because beta is the scale parameter. So how to find it? As the beta, when x value is less than equals to 10, so my function value will be what? Function value will be this one. So my function will return as 10. Now I have to define my alpha and beta. So this is basically alpha and beta. So alpha is what? Alpha is my shape parameter and beta is my scale parameter. So this is basically scale parameter is 10. That is the upper limit. But the shape parameter is when I divide the upper 10 divided by 5. So it will be 5 ones are 5, 5 twos are. So by dividing the upper with lower, so this will be my shape parameter. So shape parameter will be 2. So this is the value of, again, this is the value of f of x with the value of alpha, comma, beta. So we find that the value equals to 1 minus e power negative with the x value and beta value, that is 10 upon 10. Let's give me 1 second. It will be 1 minus e this will be 10. 10 will be my x value. So it will be alpha, sorry, beta, where the x holds into the value of alpha. So it will be 1 minus e into negative here formula. So 10 upon 10. Then the alpha value is 2. So it will be 2 here. So it will be written as 1 minus e negative 1 square. So it will be negative 1. 1 here will be 1. So it will be written as 1 minus 1 upon e. So the value is 0.632. Okay. So for similarly, I find the value of p with the value of x less than equals to 25, that it is started from 0 and it ends at 25. So 0 to 25, it will be value equals to 0.998. Okay, so these are the values basically to find the respective value of by using Weber's distribution. Okay, the next one is I have to find the value C, which separates the 5% of an engines having the largest amount of NOx emission from the remaining 95%. So my remaining will be 95%. This means that it will be 0.95 equals to 1 minus E minus of C upon 10. C basically is the separate function with the value of 2 again. So how to find C? So again, I have to write here, it is 0.95 equals to 1 minus e with a negative sign c upon 10 with the alpha value that is 2. I have to find this c. Okay, so how to find this c? So this will be 1 minus e minus c square divided by 100 equals to 0.95. So firstly, I have to place this value here. So it will be e negative c square divided by 100 will be equals to 1 minus 0.95. So it will be e negative c divided by 100 equals to 0.05. Not taking the natural log on both sides. So it will be, this will be in denominator. So it will be minus c upon 100 ln e, which equals to ln 0.05. After this, it will be negative c square divided by 100 equals to log 0.05 divided by ln e. So it will be negative c square equals to 100 multiply log 0.05 divided by ln e. So ln e will be this one. So I have to take this negative sign here. So by taking the value under root on both sides, so it will be 17.27 or respectively 17.3. So this is the C equals to as the 95 percentile of the emission distribution. So this is the way we find the value of NOx, okay, for in my pollutants. So by using this equation, it's the primary equation to find the value of pollutants. Now the next topic is log normal distribution. So for log normal distribution, we have uh, function of x, mu, and sigma. Okay. So what is x? X is the simple value, domain value. What is the mu? So mu value is what? Mu value is this one. And the second value is my sigma. Sigma value is this one. So now there are two things. Okay. So in Weibull distribution, there is f of x into alpha and beta. Okay. Now there is mu and this one. So it will be 1 upon under root of 2 pi sigma x into e negative of ln into x minus mu whole square divided by 2 sigma square. So this is the value of when x value is greater than or equals to 0. Okay. So otherwise, my all the values for this function must be equals to 0 in case when x is less than 0. So to this, we have to go to the numerical. Yes, this one. Example 4.27. Zen, hello.
Yes, sir.
Yes. I am giving you 2 to 3 minutes break. So
Yes.
yes. So go and let fresh yourself and be there in 4 to 5 minutes. Okay, let's start
Yes,
from
sir.
this example. Okay, take your time and we'll meet in 4 to 5 minutes. Okay, sir. Okay, Zen.
Yes, sir.
Okay, let's start it with this one. That is log normal distribution as I described, because the theory is very important for log normal. So I will just touch some man parameters regarding the log normal distribution. Okay, so if it is common to refer mu and sigma as the location and scale parameters. Okay, so now there are two parameters which are involving in log normal are, first is my location parameter, location parameter, that is my mu value, and second is my scale parameter. Scale parameter is my sigma value. So these are the two values that we find by using formula uh, that we have to find the location parameter and scale parameter for a given system. Let us say that my system value is E of X. So E of X equals to, for log normal distribution, okay, it will be E with my mu. Mu is y what? Scale parameter. Scale parameter plus sigma. Mu is my location parameter, sorry, and sigma square divided by 2. Sigma is my scale parameter. Again, referring to I will basically, these are the two parameters. Just give me 1 sec. Okay, these are the two parameters. First is my location parameter and second is my scale parameter. So E of X is equal to this one. Now for V of X. So E of X will be equals to E 2 mu plus sigma square with a multiple of E sigma square minus 1. So these two basically are the E of X mean. This value is my mean value, and this is my variance value. Variance of the log normal distribution. So these are the two formula. So these are the two formulas basically used to find the mean and variance for my log normal distribution. Okay. So these are basically the curves. So first curve basically is between mu and sigma. So first curve is when mu is 1, sigma is 1. That is 1, 1. Second is when mu equals to 3 and sigma value is under root 3. So it is 3, under root 3. And third one is when mu equals to 3 and sigma equals to 1. That is 3, 1. These are the three values. So first this function. Let me use this. Okay, so this graph will be for this function. This graph is for this function. And this graph is for this function respectively. Okay. Now, these are the, because log x has a normal distribution. So the CDF of x can be expressed in terms of CDF of function z of a standard normal RVZ. So the formulas are written here. So if it is f of x initial value with mu and sigma, shape and location parameters. It will be P with X is less than equals to R. Okay, so what does this means that P having X less than equals to R? So here we apply my log normal distribution. So log normal distribution says that these are the two values. First value is this one and second value is this one. So I have to add log on both with both the variables. So this means that adding, sorry, adding not, multiplying is the suitable word. Multiply log, that is ln, on both sides of inequality. So it will be P with log X less than equals to log R. Sorry, this is also the log X with smaller x, so it will be log capital X less than equals to log small x respectively. Okay, so this is the first notation when there are two multiples or two variables. In this case, there is a x and smaller x. So it will be for the log normal distribution, we have to add log on both sides. So it will be log of x and log of smaller x respectively. So this is the step one. Now in the step two, this will be that my f function with x and mu sigma, it will be P with z less than equals to log x minus mu divided by sigma. Okay, so basically this is the CDF of x. Okay, can be expressed in terms of CDF. This is CDF of x of standard normal z. With standard normal z, you have to write that CDF of x with standard normal z. Now for the second, when this is CDF with the parameter flux or phi of z, so sorry, there will be no p. It will be f of x mu into sigma. It will be phi into the log function, so it will be log x minus mu whole divided by sigma. So this value is applicable when x value is greater than equals to 0. So basically we have to find that when x value is greater than equals to 0, so my function value, this one, is equals to my flux value with the log of function minus mu divided by sigma. Okay. Now, in example 4.25, according to the article, predictive model for pitting corrosion in buried oil and gas pipelines The log normal distribution has been reported as the best option for describing the distribution of maximum pitch depth data for cast iron pipes in soil. Hmm. The author suggested that the log normal distribution with mu equals to 0.353 and sigma equals to 0.754 is appropriate for maximum depth of buried pipelines. For this distribution, the mean value and variance of pit depth are this one. Ex function will be equals to this one. Ex function equals to e power 0.353 plus 0.754 square divided by 2. This is basically, this will be written as E of X equals to E mu plus E sigma square divided by 2. Now in my case, the mu value is 0.353 mm and sigma value is 0.754, which is given to us here. Okay, so I put these values, so my E of X will be E power E mu. So mu will be 0.353, so it will be 0.353 plus. Now plus will be E power sigma square. Sigma will be 0.754, so it will be 0.754 whole square divided by 2. So after the simplification, it is E power 0.6373. So it will be written as 1.891. Okay, 1.891, the value of E of X. Now for V of X, this is basically written here. Okay, E of X value written here, this one. E of X, E mu plus sigma square divided by 2. Now V of X value is this one. I have applied step by step here. So I have to find V of X. So how to find V of X? So my V of X will be, I have to write here, V of X will be equals to E 2 multiplied by mu plus sigma square multiplied by E sigma square minus 1. Okay, so this is the formula. You have to remember it. Now, this will be easy. After applying the formula, this will be easy to compute all the values. So it will be V of X will be equals to E 2 into mu. Mu will be 0.353 plus sigma value is 0.754 multiplied by E with the mu. Mu value is 0.754 square minus 1. Okay, so for this it will be 3.57697 multiplied by 0.7656 0.765645. This will be 2.7387 respectively. Okay, so it is 2.7387 respectively. So this is how we find the value of v of x and e of x for my system. Okay. Now the probability that maximum pit depth is between 1 and 2. So again, for 1 and 2, I described earlier that I have to take the log. Okay, where is the log? Yes, this one. Take the log on both sides. So for this, it will be, I have to write that my probability with the x less than equals to 2 with greater than equals to 1 will be, now there are three parameters. Okay, you have to remember 1, 2 and 3. So it will be written as probability with the ln1 with less than equals to probability of ln with x with less than equals to probability of ln with 2. Okay, so it will be probability of ln1 is 0, 0 less than equals to ln x, and then it will be 0.693. So for this system, it will be written as P of 0.0 minus 0.353 whole divided by the maximum value, that is 0.754, which is less than equals to z, and which is also less than equals to 0.693 minus 0.353 whole divided by 0.754. Okay, so for this it will be, the value will be 0.354, and the next method is to find from 5 method, but this method is easy, that you find the value of 0.354 respectively. Okay, now this is the curve. This curve shows that at the point, the starting point, it has a 0 value, but it goes, when it goes to 1, it goes to a peak value, this point. Okay, so this point is approximately 0.47 at the time, let's say it will be 1.7. Okay, at the x equals to 1.7, my function value is at peak. Okay, but at between 1 to 2, this value, this is the area under the graph or the shaded region. This value is 0.354 respectively, and it will move in a curve and it reaches to a straight line. Straight line. Okay. What value C is such that only 1% of all the specimens have a maximum pitch depth exceeding C and the desired value satisfied. So when it is 1% of total, so it means that 1 minus 0.01. So it will be 1% means that 1 minus 0.01, which will be equal to 0.99. Okay, so it will be 0.99 probability of X, which is less than equals to C, and it will be probability with Z, which is less than equals to log of C minus 0.353 whole divided by 0.754. Okay, so this Z critical value, that is 2.33, captures an upper tail area of 0.01. So 0.01 will be 2.33 for my system. So it will be written as log C minus 0.353 divided by 0.754. So this value equals to 2.33 respectively. So yes, so we can find that the log normal density curve with location. There are two basic locations. First location is 0.353 and second is 0.754. Now from which log C equals to 2.1098, and this means that C value will be 8.247. So how to find this? As log C equals this one, so taking anti-log on both sides. So when taking log inverse, so it will be C equals to 8.247, which will be the 99th percentile of the maximum pitch depth distribution. Now next is the beta distribution. The beta distribution means all families of continuous distribution discussed so far exceeds for a uniform distribution have positive density over an infinite interval. Okay, so typically the density function decreases rapidly to zero beyond a few standard deviations from the mean. The beta deviation provides positive density only for x in an interval of finite length. So for beta distribution, it is a random variable x is said to have a beta distribution with parameter alpha and beta both positive. So my x, a and b both positive, and a and b values. If the PDF of x is, let's say function is x, then a, b, alpha, beta, a and b. So it will be written as function value with x, alpha, beta, A and B. It will be written as 1 upon B minus A into the function of alpha plus beta divided by function alpha multiplied by function of beta. So it will be x minus a divided by b minus a alpha minus 1. This will be b minus x divided by b minus a with the value beta minus 1. Okay, so these are basic function values. So the function values are 1 upon b minus a. Now the interval is x is less than equal to b and x is greater than equals to b. The case a equals to 0 and b equals to 1. It gives the standard beta distribution. Okay, it gives the standard beta distribution. So 1 upon b minus a into a plus b, then a complete function of this one, then a function of a multiple of function of b, then x minus a divided by b minus a with alpha minus a into b minus x divided by b minus a into beta minus 1. So this is a complex formula that of beta distribution. So the graphs of generally basically gives the point, a stretch point or a compressed point to a fit hour. Fit hour may be 2 points, that may be A, B, C, D or something else. So unless alpha and beta are integers, integration of the PDF to calculate probabilities is difficult. Okay, either a table of incomplete beta function or appropriate software should be used. So my new value equals to a plus b minus a into alpha upon alpha plus beta, and sigma square equals to b minus a whole square with the multiple of alpha beta, and then whole divided by alpha plus beta whole square into alpha plus beta plus 1. This will be sigma square will be b minus a whole square. B minus a whole square means is b square plus a square minus 2ba, and then the multiple of this one, that is alpha beta, then whole divided by alpha plus beta whole square. So it will be alpha square plus beta square plus 2 alpha beta with the multiple of alpha plus beta plus alpha. So this is the complete elaboration to find the sigma square. Mu is the simplest one, that it is a plus b minus a, but the sigma square having square identities, two square identities. So you have to solve the square identities first. So after solving the square identities, so you have to put the values of a, b, alpha, beta to find the values. Okay, let's move toward example 4.28. So project managers often use a method labeled PERT. Okay, so basically PERT means project evaluation and review technique. Okay, to coordinate the various activities making up a large project. So our standard assumption in PERT analysis is that the time necessary to complete any particular activity once it has been started has a beta deviation. So to execute PERT, that is program evaluation and review techniques, we use what? Beta distribution with A equals to with A equals to the optimistic time, okay, and B is the pessimistic time. Okay, so our domains are optimistic time and pessimistic time. So optimistic time is if everything goes well, it is known as optimistic time. And for pessimistic time, when if everything goes badly, that neither the work has been completed on time, so it will be pessimistic time. Okay, so suppose that in constructing a single family house, the time x in days necessary for the laying the foundation has a beta distribution with A equals to 2, B equals to 5, alpha equals to 2, beta equals to 3. Then alpha upon alpha plus beta equals to 0.4. Okay, so my E of x value will be 2. E of x I have to find by using formula, as the formula is E of x formula is alpha plus beta multiplied by alpha upon alpha plus beta. Okay, now I have to see that what is the alpha. Alpha value is 2, so I have to write here 2. What is the beta? Beta is 3. And then alpha upon alpha plus beta is 0.4, so it will be 0.4. So it will be 2 plus 1.2, so it will be 3.2 respectively. Okay, for these values of alpha and beta, the PDF of x is a simple polynomial function. So the probability that it takes at most 3 days to lay the foundation is. Okay, so the next formula. So for laying, it will be probability of x is less than 3, that is beta value. It will be 1 upon 3 with here it is beta value, and here it is alpha value. So 1 upon 3 into 4 factorial, the value of basically this parameter into 1 factorial into 2 factorial into x minus 2 divided by 3 into 5 minus x. Basically, I am applying this formula, beta formula, this formula again, this one. I apply this formula, okay? By applying this formula, I find the values of my probability across the interval. Okay, so 4, and this will be, I will be taken as it will be 3 into 2, 4 divided by 27 into x minus 2 divided by into multiple of 5 minus x square d of x. Yes. So taking this before the integral, so it will be 4 upon 27. Then the integral beta and alpha. So you remember that right here that beta value is 3. Beta is your upper limit and alpha is your lower limit. Alpha value is 2. Then the function that is x minus 2 with 5 minus x whole square. So after this, it will be 4 upon 27 multiplied by 11 upon 4. So this will make 4 and 4 will be cancelled out. So it will be 11 upon 27. 11 upon 27 is 0.407. That is 0.407. So this is the probability of x when x is less than equals to 3. Okay, the standard beta distribution is commonly used to model the model variation in the proportion or percentage. So typically this value is in proportion, okay, or in percentage of of quantity, okay, occurring in different samples, such as the proportion of 24 hours that an individual is asleep or proportion of a certain element in a chemical compound. So this is the way to find that find the probability by using beta distribution. So for beta distrib beta distribution, it will be to find in the uh, proportion and also in the percentage of quantity. So this is the values basically of regarding my beta distribution. Then any question regarding this beta distribution? Hello. Any question regarding this then? Hello. 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 Then any question regarding this
No, sir.
beta distribution? So this is the end of also the, completion of both the slides. So hopefully you understand each and every point. So I think the time also is completed. So any question regarding this?
No, sir.
Everything is clear?
Yes, sir.
Okay. So that's it. So I think if there is no question, so this is the completion of the lecture. So take care and inshallah we'll meet soon in the next lecture.
Thank you, sir.
Okay. Assalamu alaikum.